So, welcome back for the course Electric Vehicle and Renewable Energy. We have already covered some of the important aspects of this particular course. Professor Ashok has given a nice overview about what goes out and what comes in an electric vehicle. The few of the things which goes out is like engine, IC engine, and at that place motor comes in. There is another important thing which goes out is fuel tank. Now, bring back the energy storage, or we say battery pack. There are several other things which goes out. I will not talk in details, if you see that different types of mechanically driven pumps that get replaced by electrical driven motors and pumps, and overall architectures almost remain same other than the placement of the battery pack. If it is like a retrofitting or existing IC engine vehicle has to be converted into electric vehicle, in that case mostly we try to fit the battery pack or energy storage wherever the space is available, and generally it comes during the second row seats, nearby second row seats. However, in some of the vehicles you may find the energy pack at the or battery pack at the rear part of the vehicle or in front of part of the vehicle. A pure electric vehicle, when it is designed from the concept, mostly you see the battery pack is placed at the bottom part of the vehicle, and it is more for the stability and the space utilization for the vehicle. That was the first chapter. Then he also talked about the vehicle dynamics, what should be the power, capacity, voltage, current requirement of the vehicle in different driving conditions, like if you go to uphill, downhill, flat road, and all the conditions. So, what is the force required, what is the power required, these all the things is discussed by Professor Ashok. Later he also discussed about the complete EV infrastructure, like charging station, the battery pack manufacturing, motor and controller, and other aspect of the vehicle. Finally, he has talked about cells. The cell, how to select a cell, how to test a cell, what are the types of cell, what are the chemistries of the cells. Having all those things done, I am going to start with the how to make a battery pack, and the chapter 5 is the fundamental of battery pack design. We will talk various aspects of a battery pack design in this particular chapter. However, since you have already done, since he has already explained very nice about cells chemistry, I will not go through much on that. I will select one of the cells from that, and then we will move forward in this particular chapter. So, let us start chapter 5, fundamentals of battery pack design. So, what does a battery pack needs? What you see right side is a BIW, body in white of a vehicle, or I do not say even BIW, it is basically a chassis of the vehicle, electric vehicle, where what do you see? This is a battery pack, drivetrain including motors, and the wheels, suspension and other thing, and the body part comes over this and sits, which also includes other system like air conditioning system. Then you have steerings, dashboard, seat belts, airbags, all those things comes as a top to this one. So, basically what does a battery pack need? It needs a robust electrical design. Why it would require a robust electrical design, we will talk. Should have sufficient mechanical robustness. It is an important aspect of the battery pack, so that whatever the condition, whatever the road condition, whatever the driving condition, whatever way driver want to drive, it should be intact, it should be performing, and it is not only performing for a couple of days or couple of times, it should be performing for the complete lifetime of the battery pack. Thermal stability. As you know that lithium ion battery packs, if not handled properly, could create a big problem, especially on thermal side. What happens? Every charge and discharge cycle, because of its internal resistance or internal impedance, it keeps generating heat, and if it is not managed properly, could lead to the failure of the battery pack. In extreme cases, it could even lead to the safety of vehicle as well as the passengers or human. The next important aspect is safety. Whatever the condition, the battery pack should always be in safe environment while running or while stationary, while charging, while discharging. In all the condition, the battery pack should have its safety intact. Life is important parameter for a designing of a battery pack. What happens in IC engine vehicle? You just have to design a fuel tank, and fuel become revenue item. That means whenever you require, you go get it filled. Fuel tank cost is very less. However, in the case of electric vehicle, the battery pack is capital investment. That means you have to pay upfront for the whole storage, and it's quite high. It's almost 50% of the vehicle cost most of the time. So, when you are putting that much of cost, you wanted to take maximum out of it. That means it should run for maximum period, maximum number of cycles, and that is what life means. Durability. What durability says, it should not run good only first time. It should run good, it should perform well in each and every time whenever you wanted to run the vehicle till its the complete life cycle. And then last is performance. Performance become important parameter because again the first thing is the cost. As I said, the initial cost is huge, that means your capital investment is huge. So, it should perform to the best, maybe 99% efficiency, maybe at 100% efficiency. And when I talk about efficiency, it is not only charge and discharge cycle. Every time you take out the vehicle, it should run as it was in the first time or as it was at its best. Then only you would be able to justify the cost involved in that. So, what I say, electrical design, mechanical robustness, thermal stability, safety, life, durability, performance, all these things are required for a battery pack. You miss any of the item from this, your things will not work properly. The next slide talks about battery pack development process. What are the things involved in a battery pack development process? So, we will go one by one. The battery pack require a proper electrical design. If I have to segment a battery pack, what are the things we require? How we could develop a great battery pack? We have to understand all of these aspects and then work towards each of details from these 4-5 designs. The first one is electrical design. Why electrical design comes first? The reason is very simple. What you require first? You require what should be the voltage, or even before that, what should be the capacity. This is what we have learned in the vehicle dynamics chapter. What should be the capacity of the battery pack? Now, as soon as you know the capacity, then you would require what would be the current requirement or what would be the C rate requirement, both during the charging as well as during the discharging process. Now, once you know what is the C rate, so you understand what you can bring back what would be the current requirement from the C rate. So, capacity, then current requirement. Once you have these two things, then you also have to find out what is the voltage. What is the voltage required by your drive system, that means motor. What are the voltage required by auxiliary system like air conditioning system, steering system and all those things. And then once you have all those things, then what you require, how to connect. While connecting, what would be the requirement of those connectors which can handle such currents and such voltages. So, that is why the first things what we have to work out for a battery pack is a proper electrical design. Now, once we have the electrical design done, what we require, then I need to provide a casing in which all these design parameters can be put on. Now, the second sets of questions comes, what would be the weight of the battery pack? Now, once we know what would be the weight of battery pack, then we will design a casing which can sustain that weight. Another set of question comes from the vibration or road conditions or the driving condition. What would be the vibration on the road, or what it should take care during the running the vehicle on the road. So, that set comes from again from in the mechanical design, that my battery pack should be like, or my mechanical design should be like which can take care of its self weight, its vibration. The another sets of questions comes from the similar thing, what cell requires. Is there anything specific which required to be done to maintain the cell life for longer time. So, one of that important aspect comes the pressure, uniform pressure over the surface of the cell. Now, when we talk about different types of cell, like when you talk about cylindrical cells, the good thing about cylindrical cell is that pressure is equal in all the surfaces. So, you do not have to worry much about the pressure, the stress concentration at any places, because pressure is uniform over the surface. Now, but when you talk about prismatic cells or pouch cells, now it is basically in cube type of thing. So, at the corners the stress concentration becomes large, however, at the center deflection becomes more. You do not want to have any of these things, neither you want to have the stress concentration more, nor you wanted to have the deflection more at some places, because what happens during every charge and discharge cycle, the cell slightly expands and contracts, and if this expansion and contraction is not uniform all over the surface, then the cell life goes down drastically. So, this is a specific requirement for the cell. So, that has to be taken care during the mechanical design. So, what are the things we have to take care of during the mechanical design? The first one is the weight of the battery pack. The second is the vibration. Third is if there is any particular requirement for the cell. The next important design aspect of a battery pack comes with proper thermal management. Lithium ion cells are well suited for a particular temperature band. When I say particular temperature band, it is mostly between 15 to 35 degrees centigrade. If you talk about India, we have a temperature, ambient temperature itself, which can go to 50, 52 up to 55, the places like Rajasthan. In Leh and Ladakh, it can go to negative temperature like minus 10 degree, minus 20 degree, and the vehicle would run everywhere. This battery pack will go everywhere. So, a thermal management system, a proper design of a thermal management system is become important to keep the temperature within the 15 to 35 degree for the best life of a cell. Why again life comes? Because it is a huge investment initially. So, you want to take out the maximum benefit of that investment. While charge and discharge, so when vehicle is running, it is a discharging, and then when you are trying to put back that energy, that is basically a charging. During charge and discharge, we have learned about fast charging, slow charging, everything in the chapter 4, chapter 3, chapter 4 mostly. What happens? cells get heated up. Now, as soon as cells get heated up, the temperature starts, it generates some thermal energy because of the resistance or impedance of the cell. Now, when that happens, cell temperature keeps on increasing. So, you need to take out that the energy generated or thermal energy generated efficiently, so that your cell temperature does not exceed to your upper limit. Or even sometime when we are unable to put a active thermal management system, which we will talk later in the thermal design, thermal management, even you are not able to maintain that temperature, you want closer to that temperature, and that requires a very detailed design. Next comes, which is the brain of a battery pack, is battery management system, BMS, and a firmware which can run this BMS system. So, BMS is basically the brain of a battery. It controls everything, all safety aspects, charging cycle, discharging cycle, temperature. It counts how many cycles it has charged, it has discharged completely. What is the capacity available in the battery pack? How many more kilometers a vehicle can run? Any safety aspect or protection, is my temperature is going beyond some certain limit which I have set. It also communicates from outside world or within the subsystem of the vehicle, like with the motor, dashboard, auxiliary systems, that what it is required, what it requires now, how much current it requires. It helps to maintain the battery pack always in usable condition. It records if there is any abuse happening in the battery pack. Its cutoff if any threshold exceeds. It's isolate in the case of crash or any safety concerning event. It's monitor each and every parameter like voltage, current, temperature of each cells of a battery pack. It balances the cells so that the life of the battery pack can be increased. So, the battery management system, especially in lithium ion battery pack, plays very important role. It helps you to increase the life, it helps you in efficient power delivery, it helps you in increasing the efficiency of the battery pack, it helps to prevent any safety concerning events, it helps you to get a great life from the battery pack without compromising anything on performance. And how does it do? It is a combination of electronics, embedded system, hardware, and embedded software, which we say firmware. Having said the development process of a battery pack, we also need to understand the need of a battery pack. Electrical design, it helps in finding the right capacity, right voltage and current. If you do not know, or you might be knowing, any voltage, any DC voltage beyond 120 volt is harmful for human. In fact, it up to 120 volts also can be harmful, but it is considered too safe for human touch. So, when we make a battery pack, depending upon the capacity and current requirement, voltage can go as high as 1100 volt, 1200 volts or even more. It is quite common, 350 volt, 700 volts, 850 volts, these are quite common voltages now. If somehow because of any reason, if that high voltage part is touching the chassis of the body, so in that case you are directly exposed to the high voltage DC, high voltage DC. It won't give you a chance like AC where you get at least a chance to get away from that place because of your sensory feelings of your body. So, in such cases high voltage isolations become important. So, that if there is any reason, if because of that chassis is at higher voltage because of a fault in the battery pack, this high voltage isolation makes sure that battery pack is cut off, or it informs you please do not touch. In short circuit scenarios, when we talk about short circuit scenarios, what happens in short circuit scenarios? Huge amount of current flows. Now, in universe nothing is having zero resistance, there is at least some resistance there, and if huge amount of current flows, then there is a heating or heat gets generated. How? I square R. So, I is already huge and the square of that, and there is some resistance always present. So, first of all, because of huge current, a lot of component can fail because it goes beyond their safe limit. The second, it start getting heated up because of the heat joule heat generated. Now, when it start heating up, the temperature can go to 300 degrees to 600 degrees, 700 degrees centigrade. If not taken care properly, if current path is not disturbed, if it is not disconnected, the melting of that particular portion takes place wherever the short circuit happens. It can result in the fire, it can elevate the temperature locally, it can melt that portion wherever the short circuit and affect the nearby component. Now, temperature is again a big problem for lithium ion batteries. Now, your local temperature is going up and up. If there is any cell nearby in contact, the cell temperature start increasing. Now, when cell temperature start increasing, a lot of things internally happen. Separators get melted, cathode, anode can get short circuited internally, can result in thermal runaway, can result in huge fire. So, electrical design should take care of such short circuit scenarios. As soon as short circuit happens, it should disconnect, it should stop the power supply, it should stop the energy flow, so that nothing goes beyond the limit or nothing else get damaged nearby. The another important aspect is efficient power delivery. What happens in the battery packs? Generally the current in the range of hundreds of ampere is taken. Even for small two wheelers, you require the current in the range of 30 amp, 40 amp, 50 amp to 100 amp. In the case of four wheelers, you require a current in the range of 200 ampere to 400 ampere. In the case of trucks and buses, again you require a current of 400 ampere, 500 ampere. So, there is two way. You increase the voltage, so your current comes down, and whatever current is there, that should able to flow as per the requirement. And for that, what you have to do? You have to design a proper bus bar with the least resistance. Sometimes it may not be possible to have a single bus bar which can take up of that much of current. So, then bus bar means a path, current flow path, and if that is not possible to have only one path, then we divide the path into multiple paths, and then we have to ensure that each path should go with the equal current at the place where it gets originated and where it gets used, at both the places and in between that also, to make equal current, then in multiple paths, So, we are dividing currents in multiple paths. When we are dividing current in multiple paths, the resistance of each path has to be same, because we wanted to take the equal current from each of the path. So, we have to ensure that resistance of each of the multiple path is the same. Then only we can say or ensure efficient power delivery. The second becomes mechanical design, very important for safe structures. When we say safe structure, even in the case of crash or toppling of the vehicle, the battery pack should be safe. Now, design should be such a way that the cost of the battery pack becomes minimum. I cannot reduce the cost of the cell, but I can still reduce the cost of the battery pack. What are the factors? Material, a design which can help me to assemble more and more packs in the less time. So, that is what is the productivity. A reliability, a pack which can last for its whole lifetime. Pack should be easily assembled, because assembling again require either a main power or machine power, and both are cost addition. If I design a pack which could be easily assembled in the least time, I am saving the cost. If something happens in the pack, I cannot simply discard it, because it is a huge cost. It should be we should be able to service it easily. If I do both, I can still reduce the pack cost. Every kg of the weight increase in the EV reduces your range. Watt hour per kg of cell is increasing day by day. That is the one thing. Can I use a lightweight material like some alloys of aluminum instead of mild steel, or some high strength steel, or something like carbon fibers to reduce the weight, let us suppose by 20% or 10% or 50%. So, every kg reduction in the weight of the battery pack would help to improve the range of the battery pack. Thermal design, from where we are taking the energy to run the thermal management system? We are taking the energy from the battery pack only. So, if my energy efficiency of the battery pack is good, I can say great, I will take minimum energy to take out the heat generated by the battery pack. That is one way. The another way, if I am maintaining the temperature, right temperature, the flow of currents becomes smooth, it becomes much easy if it is at elevated temperature or at lower temperature. That helps in improving the life cycle. A thermal design should take care if there is any thermal accident going to happen. It should mitigate, if at least it cannot diminish, at least it should mitigate the effect of such thermal accident. It helps in increase cell life and ultimately the pack life. So, it has to take care of several things: temperature uniformity within the pack, minimum possible energy it should draw to maintain the pack at some particular temperature. BMS design, it keeps all safe limits, it keeps recording, it keeps checking all the safe limits of the battery pack and acts whenever it breaches, prevents any safety related events. Like in the case of crash, you do not want energy to be flowing, at least you want to keep it isolated if you cannot dissipate in proper manner. It controls all the subsystem including thermal management, balancing, measurement, data recording, all the things is being done by BMS. So, next is the stages of a battery pack design. In the chapter 4, what we have talked about the cell configuration to what would be a cell configuration in parallel and series combination to bring the capacity like AH, voltage and the current. And what we say that is NPTEL-NOC theory. A series combination will increase the voltage, multiply the voltage. A parallel combination will increase the capacity or AH, ampere hour, and both things together will give you the required capacity and the required voltage. Then comes structure. When we say structure, it is a case, different covers, end plates, tie rods, cell holder, base plates, etc. And these all are mechanical parts. If we have to categorize, these all are mechanical part. What others? Then we have bus bar, wiring harness, fuses and plugs. This all comes electrical part. Then we have cooling jacket, safety valves, thermistors. These all are thermal parts, and this whole together makes a structure. What are the things related to safety? Once you have a structure, then the next thing what you worry about is safety. Vibrations, shock abuse, crash, and these all things you have to mitigate using the mechanical design. Another safety events, short circuits, overcharge or over discharge, and that you have to mitigate using electrical design. Thermal runaway and ultimately thermal management, that comes under your thermal design. Then it becomes controls. What are the controls? Is there any sensors which can help if particular vibration level is increasing or a vibration level is increasing to cut off the pack or to reduce the functionality. So, again the sensors and the control part would be a mechanical part or part of the mechanical design. Cell monitoring and BMS, how can you do? You need to have a wiring harness, you need to have the proper sensors. So, this becomes a part of electrical design. Then protection, SOC, SOH, range, life, various measurements and controls becomes of the part of embedded system. And then application, interface, talking with other subsystems like motor or dashboard. Again it is a part of embedded system. Telemetry, if owner wanted to know or some person wanted to know what is the leftover in the vehicle, how many more kilometers it can go, what is the energy status, what is my pack status, is the battery functioning well, can be done using the telemetry, again the part of embedded system. We will discuss about now what are the major components of a battery pack. What I am showing you exploded view of a small battery pack. We have battery cells here, then we have a compression pad or insulation pad or both together in between the cells. If you see in between the cells from here to here. Then we have a plastic cell holder that isolate from one cell to other cells or one module to other modules. So that there should not be any current leakage. Then we have bus bar and bus bar holders which helps in efficient power delivery. Then we have side strips. I will tell you why it would be required. when we will come to the mechanical design. Then we have end plates. This end plates and the side strips both together helps in maintaining the required pressure on the cell, so that it should not bulge out during the charge and discharge cycle. Then we have base plate. This base plate helps in taking care of the weight of the battery pack as well as the road load, vibrations conditions. Then we have thermistor and voltage sensor for monitoring, and if anything exceeds within the limit, to control. Then we have wiring harness for monitoring as well as for efficient power delivery from the pack. Then we have a BMS. These all the sensors are connected to the BMS, which keeps on monitoring each and everything of the battery pack. Then we have outer casing to protect each and everything from the environmental condition, and also it helps to take care of the battery load or battery weight and the road load condition. So, with both this outer casing and the top lid together make the whole battery pack. So, you see here in this small video how the pack is getting assembled with each and every aspect. Initially, you make cells parallel and series combination, put the bus bar, cover it into the plastic casing, put end plates, bottom plates, tie rods together, clamp all the things, fix the BMS and put it into the outer casing. Now, this battery pack is ready for use. We have discussed the 4 design aspects: electrical design of the battery pack, mechanical design of the battery pack, thermal design of the battery pack, and then BMS and embedded system or firmware. We will go one by one and we will discuss all the aspects of that particular design aspect.